Okay, everyone, good morning. I want to talk a little bit about the ideal gas law. So today is 4:10, Thursday, the 10th of April, and nobody showed up to Teams meeting, so I wanted to make a video about what I was going to talk about today. So this is Unit 7. It's all about gas laws. There's quite a few of them, and there's quite a few assignments and problems with math. So I wanted to talk about the ideal gas law and do one or two problems for you. So ideal gas law, as it says here, equation used to describe the state of an ideal gas. So like if all conditions were perfect, then the ideal gas law would produce these values and these numbers, or predict different volumes, different amounts of the gas in moles or in grams, or predict the temperature if everything was perfect. So ideal gas is a theoretical gas, follows the kinetic theory of molecular gases. Here's our kinetic theory of molecular gases. So if we're talking about an ideal gas, it is going to follow all 5 of these things. I'm not going to read them off because I want to get to the meat of it. So I'm going to start with the ideal gas law equation. So ideal gas law equation is P times V is equal to nRT. So P is, of course, pressure. You guys should know that by now. And it has to be in atmospheres. Oh, let's try that again. And again. And it has to be in atmospheres. And most of the time, the problem will give it to you in atmospheres. Volume, V is volume. And this has to be in liters. So if they give you it in milliliters, okay, what you're going to have to do is you are going to convert from milliliters to liters. So you're going to have to divide that value by 1,000 to give you your answer in liters. N is equal to moles, or represents moles. So if you are given a value in grams, you have to convert to moles using the molar mass of the substance. Or if you are given grams, you're going to have to convert it to moles using the molar mass to solve your problem. I'm going to jump to T. T is temperature, and that has to be in Kelvin. So if you're given it in degrees Celsius, you're going to have to add 273.15 to get your temperature in Kelvin. And the last but not least, R, which is brand new to you guys. R is the ideal law gas constant, or the ideal gas constant, and that equals 0.0821 liters times atmospheres over moles times Kelvin. So that is why it is really important to have all of these units or all of these values with the proper units, because you're going to have to be canceling things out. Okay, so quick lesson on rearranging variables. So PV is equal to nRT. If I'm solving for pressure, I'm going to have to divide by volume on this side. So my new equation is equal to P is equal to nRT divided by V. So let's say I need to solve for volume. I'm going to divide by pressure on both sides. So volume is equal to nRT divided by P. Say I have to solve for temperature. I'm going to divide by nR on this side. Whatever I do to one side of the equation, you got to do to the other. So my temperature equation would be PV divided by nR. If I have to solve for N, so PV is equal to nRT. If I'm solving for moles or grams, you have to solve for N. So the only way to get to grams is to solve for moles and then convert it to grams. So if I need to solve for moles, I'm going to divide by N, or R and T on each side. So my new equation, N is equal to PV over RT. Okay, so let's get to a few practice problems. So it says determine the moles of gas contained in a 750 milliliter container at negative 50 degrees Celsius with an with a pressure of 0.921 atmospheres. Have the volume include 3 decimal places. So it says determine the number of moles. So I'm going to start with my original equation. I'm going to put it up here. So I'm solving for N. So I'm going to divide by R and T on both sides. So N is equal to PV over RT. Okay, now I'm going to look at the rest of my stuff. My volume is in milliliters and I need it in liters. So I'm going to take 750 milliliters and I'm going to divide it by 1,000 milliliters is equal to 1 liter, 0.75 liters. That's my volume. My temperature is in degrees Celsius. So if I want Kelvin, I'm going to have to take my negative 50 degrees Celsius and add 273.15. And that is going to get you to, so 273.15 plus negative 50 is going to give me 223.15. That's Kelvin. Now I'm ready to solve for N. So N is equal to pressure. They tell me my pressure is 0.921 atmospheres. Multiply it by my volume, which is 0.75 liters, all divided by R, which is 0.0821 liters times atmospheres over moles times Kelvin. That's my ideal gas constant. And then, of course, my last is my temperature, which is 223.15 Kelvin. So at this point, I'm going to grab my calculator, and this is how I'd like to plug it in. 0.921 times 0.75 is equal to, divided by, I put everything on the bottom in parentheses. So on the bottom, I'll put parentheses, 0.0821 times 223.15, close parentheses, is equal to, N is equal to 0.0377 moles. Okay, I'm going to do one more, I think, for you guys, so I don't run out of time here. And I think I'll start with this one. So it says, at what temperature will 6 grams of neon exert a pressure of 6 atmospheres at a volume of 500 milliliters? So there's a few things. You definitely need your periodic table when doing these problems, because this is a problem with stoichiometry. So let's start with what we are solving for. We're solving for temperature. So PV is equal to nRT. So we're solving for T. So I'm going to divide by N and R on both sides. So my new equation is temperature is equal to PV divided by N times R. Now there's a few changes we have to make. Our pressure's in atmospheres, so that's good. Our volume is in milliliters, so we've got to convert that. So 500 milliliters, I'm going to have to divide it by 1,000. So my volume is now 0.5, whoa, let's try that again, 0.5 liters. And I got to do one more conversion because my mass is in grams and I need it in moles to use my equation. So I'm going to have to do 6.00 grams of neon. I have to convert this to moles. So I'm going to go to my periodic table of elements, find the molar mass of neon. So the molar mass of neon is 20.0 20.18 grams of neon. Whoops. Where did I go? There we go. 20.18 grams of neon is equal to 1 mole of neon. So grams cancels each other out. I'm going to do 6 divided by 20.18 is equal to 0.297 moles of neon. Now I'm going to use that in my equation. So temperature is equal to the pressure is 6 atmospheres. My volume is 0.5 liters. My moles is 0.297 moles. And R is my ideal gas constant, 0.02. Try that again. Just inverted those numbers. 0.0821 liters times atmospheres over moles times Kelvin. So atmospheres gone, liters gone, moles gone, and I'll be sitting with Kelvin. So again, I'm going to do 6 times 0.5, and then I'm going to divide it by, I'm going to put open parentheses, 0.297 times 0.0821, close parentheses, and that will give me a temperature of 123 Kelvin. Okay, so I'm about to run out of time, so hopefully that helps. Let me know if you guys have any questions. Have a wonderful day.